Students, the topic that we are going to cover today is first of all that the topic we have to cover is rules for significant significant figures, rules for significant figures in addition, subtraction. So rules for significant figures in addition, subtraction, multiplication, uh, multiplication, multiplication and division. Now we have to understand rules for significant figures while adding, subtracting, multiplying and dividing. Now the first thing is rules for addition and subtraction. So when you add and when you subtract, so we can say that the answer of addition and subtraction, the answer of addition and subtraction must be according to the least precise data. It must be according to the least precise data. Now, what is meant by least precise data value? Least precise data value is least precise data value. Least precise data value is the value taken from the, so basically least precise data value is the value taken from the least precise instrument. No, what is meant by least precise instrument? Basically, least precise instrument is least precise instrument is the instrument with the highest least count. Now let's understand an example. We write some reading and their least count. Let's suppose reading and then least count of the instrument. Least count of instrument. So for the given readings, we have to see that what are the least counts of the instruments. You have a number 1, 2, 3, 4.22. Then you have another number 0.0015. Then you have another number 0.2. No, you have three numbers, and just for example, they are readings. Let's suppose they are readings of current. They are in amperes. Now, if these readings are readings of current, then the precision of the emitters from which they have been taken, the precisions of the emitters from which they have been taken can be discussed. Just for example, the least count of the instrument for the first reading is 0.01 ampere. So here it is 0.01 ampere. Least count of the second instrument is 0. You see, it is 0. It is 0.0001 an ampere. So least count is basically the last significant digit, the digit at the rightmost position. That digit represents the least count. So least count is the smallest value that an instrument can be. For this instrument, the least count is 0.1 ampere. Now, out of all these currents, which current is the most precise and which current is the least precise? Now, the most precise one is this one. It has the smallest least count. So this reading 0.0015 ampere has been taken from an instrument with the, you see, with the smallest least count. So this reading is the most precise. This reading is the most precise reading. On the other hand, the 0.2 ampere is taken from an instrument with a least count of 0.1 ampere. So this reading is the least precise reading. So this reading is the least precise reading. Now, if we add these three numbers, then the answer will follow the least precise one. That is 0.2 ampere. The answer cannot have more than one decimal. So, just for example, if you're given a question, let's suppose someone asks you, calculate x, and x is equal to 0.2 plus 0.0015 plus 1234.22. Now, you can find the answer from calculator. However, you can find the answer of this calculation from calculator. However, one thing is important, that is, how will you write the answer up to correct significant figures? How will you care about the significant figures? While adding or subtracting, we do not care about significant figures, but about the decimals or precisions. So, when you are adding or subtracting, care about precision. Now, what is precision? Precision is, in simple words for your understanding, decimal points. So, in simple words, we can say that the answer so when you are adding or subtracting, you must know that your answer cannot be so your answer so when you're adding or subtracting, you have to be careful. Your answer cannot be more precise than the least precise data value. So the answer cannot be more precise than the least precise data value. So here precision is about decimals. So here you see 0.2 has 0.2 has, you see, it has one decimal. 0.2 has only one decimal. 0.0015 has four decimal places, and this number has, you see, two decimal places. Now if we add these three numbers, the answer cannot have decimal places more than one, because this number 0.2 is the least precise number. The 0.2 is the least precise number. So the answer cannot have more than one decimal. So if we add these three numbers, you see one of the numbers is 0.2. The second number is 0.0015. The third number is 1234.22. Now if we add these numbers using calculator, the calculator will return an answer of 5124.4321. But the answer has incorrect significant figures. This answer is not acceptable because you see the least precise data has only one decimal place. This is the data that is least precise. If the least precise data has one decimal place, then the rule is that answer can only have one decimal place. So if the least precise data has only one decimal place, then the answer should also have only one decimal place. So an acceptable answer would be 1234.4. So this is the answer that is acceptable. This answer will be acceptable. Now, if you go for subtracting two numbers, let's suppose someone asks you to subtract 1 point, you have a number 1.24379. Someone asks you to subtract 0.01 from this number. Now you see, you have two data values to be subtracted. First of all, which one of them is least precise and which one of them is more precise? If you focus on this value, it has 1, 2, 3, 4, 5 decimal places. This value has 5 decimal places, as you see. The second value, this one, you see it has 2 decimal places. So 0.01 has 2 decimal places and 1.24379 has 5 decimal places. Now if we subtract these two values, what would be the answer that we get? You see, here you will get a 9, here you will get a 7, here you will get a 3, here you will get a 3, then you will get a 2, then you will get a 1. This is the answer given by the calculator. So if you put these two values in the calculator, this is the answer that you will get. But this is not acceptable because we have not followed the right precision. So out of the data values, 0.01 is the least precise. 0.01 was the least precise data. And you see, and it has only 2 decimal places. Hence, so our least precise data was 0.01, and you see it has 2 decimal places, and hence the answer can only have 2 decimal places. So answer of this answer should be written up to 2 decimal places. As a result, the answer should be 1.23. This is a correct answer. So while adding or subtracting, care about precision or decimal places. What about multiplication and division? Rules for multiplication, division, and power. So when you multiply, you divide, and you go for power of a number. Then the rule is that the answer will have significant figures according to the data value with least significant figures. So when you multiply, divide, or go for a power, then the answer will have significant figures according to the data value with the least significant figures. Just for example, if someone asks you to multiply 1247 with 1. Now you see these are 2 data values and they are to be multiplied. So you have to multiply 1247 with 1. The answer would be, if you use calculator, the calculator will return an answer for this question, that is, calculator will return an answer of 1247. But the problem is that calculator has no idea about significant figures. You have to decide the significant figures. You see, 1247 has 4 significant figures. 1247 has 4 significant figures. This one has 1 significant figure. So this has 4 significant figures. This has 1 significant figures. No, the answer cannot have more than The answer cannot have more than one significant figures. However, sometimes you are allowed with one extra significant figures. So we can say that the least significant data that is one has only one significant figure. The least significant data that is one has only one significant figure. Hence, the answer can have one or two significant figures. So by principle, either the answer will have significant figures according to the least significant data, or it can have one more significant figure. So the answer that you calculated, this answer is not acceptable. A correct answer could be if you write your answer up to one significant figures. So you can write it up to one significant figures, or you can write it up to two significant figures, because your least significant data has one significant figure. So the answer could be written up to one significant figure or two significant figures. Up to one significant figures, it would become 1000. And up to two significant figures, it would become 1200. Both of them are acceptable. So the answer could have one significant figures, or it could have two significant figures. I think it should be clear. Now we see one example about division. If someone asks you, calculate a number y that is equal to 1243 divided by 0.1. Now you see, if you have two data values, one is 1243 and the other is 0.1, then how many significant figures each data value has? You see, here you have 4 significant figures, and here you have only one significant figure. So this number has 4 significant figures and this number has one significant figure. Now as a result, if you divide these two numbers, the answer would become 12430. But this answer is not acceptable as the significant figures are not correct. Now least significant data, that is 0.1, has one significant figure. So the least significant data, that is 0.1, has one significant figure. Hence, the answer can have one or two significant figures. So if the least data has one significant figure, then either the answer will have one significant figure, or it can have one significant figure more, that is two significant figures. So your answer, if you want to write it correctly, the answer should be written as, you have two possibilities. If you write it up to one significant figure, it would become 1000123 zeros. And if you write it up to two significant figures, then your answer would become, up to two significant figures, it would be You see, it would be 1, 2, and all the zeros. So your answer up to one significant figure and your answer up to two significant figures. So these are the rules for significant figures that you have to follow, and otherwise your answers and your lab work or practical will not be acceptable. You have to care about the significant figures. This is one significant figure, and here this one has two significant figures. So these are the rules for significant figures. One remaining thing is, what are the rules for constant? Sometimes we have some constant. So significant figures, you should say that rules for significant figures for constant. Rules for significant for constants. Basically, what is meant by this topic is that sometimes you have formulae in which you have some constants. Like if you write a formula Ke is equal to 1 over 2 mv square, then you see in this formula Ke is a data value, m is a data value, v is a data value, 1 over 2 is a constant. 1 over 2 is a constant. While calculating, significant figures present in a constant value are ignored. Constants have no significant figures since constants are not taken from the instruments. So we can say that when you use this formula, Ke is equal to 1 over 2 mv square. If you perform some experiment to calculate kinetic energy is 1 over 2 mv square, then m will be taken from some instrument. So m is taken from some instrument. You use some instrument for the mass to calculate m, so it will have significant figures. Achha, in the same manner, v is taken from instrument. So for v you will also use some instruments, hence is taken from instrument, so it also has significant figure. 1 over 2 is not taken from any instrument. It is just a constant that will always remain 1 over 2. So this 1 over 2 cannot change. 1 over 2 is a constant. For this formula, it is not taken from any instrument. So it has no significant figures. 1 over 2 has no significant figures, and it has no role while determining the significant figures of the answer. So while writing the answer, care about significant figures of data values which are m and v, however, but not about the constant that is 1 over 2. So you'll ignore the significant figures of constants present in the formula. So constants present in the formula, their significant figures are ignored. They have no significant figures. So significant figures are only for the values which are taken from some instrument, not the constants. Students, Today we have to study up to this point. So this was the topic for today.